Have you ever wondered how traditional network devices, like firewalls or routers, are evolving beyond dedicated hardware appliances? Picture a world where these essential functions aren't tied to a specific box but can instead run flexibly on standard servers, adapting to your network's needs with remarkable agility. This shift represents a fundamental change in how networks are built and managed. At its core, a virtual network function, or VNF, operates as a software implementation of a network function that traditionally ran on proprietary hardware. Within Network Functions Virtualization, or NFV, these VNFs are decoupled from the underlying hardware, allowing them to run on generic computing resources, such as virtual machines or containers, hosted on standard servers. This means that instead of buying a dedicated physical appliance for a firewall, you can now run a firewall VNF as a piece of software on a virtualized server, making your network infrastructure much more flexible. The primary reason this approach works so effectively is the principle of virtualization. NFV leverages virtualization technologies to abstract network functions from their underlying hardware. This abstraction allows multiple VNFs to share the same physical computing infrastructure, forming what is known as the NFV infrastructure, or NFVI. Crucially, a management and orchestration layer, often called MANO, oversees the entire lifecycle of these VNFs. It handles everything from initial deployment and configuration to scaling and termination, ensuring that resources are dynamically allocated based on demand. This separation of software from hardware provides unprecedented flexibility and efficiency. Operationally, VNFs are deployed onto the NFVI as virtual machines or containers. Once deployed, they perform their specific network task, such as routing traffic, encrypting data, or performing load balancing. Network services are then created by chaining multiple VNFs together in a specific order, forming a service chain. For example, incoming traffic might first pass through a firewall VNF, then a network address translation VNF, and finally a load balancer VNF. This chaining is all managed by the MANO layer, which can dynamically adjust the order or add new VNFs as needed, responding to changes in network conditions or user requirements. This dynamic architecture introduces several key advantages. One is resource pooling, where computing, storage, and networking resources are abstracted and shared among multiple VNFs, leading to better utilization. Another is service chaining, which enables the flexible creation of complex network services by linking individual VNFs. Most importantly, it introduces elasticity, allowing network functions to scale up or down automatically in response to varying traffic loads, without manual intervention or expensive hardware upgrades. This agile scaling is a cornerstone of modern, software-defined networks. Ultimately, the way virtual network functions operate within NFV revolutionizes network management by transforming fixed, hardware-dependent services into agile, software-driven capabilities. This paradigm shift delivers a network that is not only more adaptable and resilient but also significantly more cost-effective. By enabling network operators to quickly provision, scale, and manage services using standard computing resources, NFV lays the groundwork for highly dynamic and programmable networks that can meet the ever-changing demands of digital transformation.
If you love understanding how the web works, like, subscribe, and stay connected with us.